Alright, so today we're looking at sequences, alright? We need to make sure we know the two different types of sequence and also how to find different terms of a sequence. Sequences are all patterns, okay? So you're recognizing a pattern, trying to pick out what's going on with the numbers, alright? That's essentially all we're doing when we're working with sequences, right? So, to start out with, first of all, we had two types of sequences. We had arithmetic and we had geometric. Alright, so to start with arithmetic ones, does anyone remember what an arithmetic sequence is? Okay, what's the first thing you learned to do when you were doing arithmetic? Okay, you learned to add, right? So an arithmetic sequence, it's easy to remember, it's something where you're just adding the same amount to get from one term to the next. Or subtracting, because we could have it being a difference, okay? So for example, we could have like 5, 9, 13, 17, 21, and so on, okay? So in this case, I'm adding 4 every time, okay? Adding 4. And I could keep going. And the reason why these sequences are significant is because I could figure out, hey, what's the 100th one going to be without having to find the first 99.
Oh.
Okay, well, let's think about it. If I know I'm adding 4 every time, and I started at 5, how many times am I going to need to add 4 to get to the 100th thing in my list?
A lot, 100 times.
Not 100, because I'm starting at number 1, right?
96.
90.
96 is 99, my guy.
Why 96?
Oh no, 99.
99. I got to take 99 steps to get from the first term to get to the 100th term, right?
So wouldn't it be 99 times 4?
So I'm going to add 4 99 times. And that would give me the 100th term of this sequence, okay? So the 100th term is the first term.
Wait, why is it 4 times 99?
Here's 99 times you get to the 100th thing in the sequence, because the first number is 5.
Okay? Now, we're going to learn this a little more formally so you have a formula you can use if you like using formulas. But this is the concept, okay? It's the first term plus 4 times the number of steps. Okay? The number of steps you have to take to get from number 1 to number 100. Okay, which in this case is 99. All right. Now, let's look at this a little bit more formally with actual notation that we're using, okay? First of all, this 4 is what's known, we often use the letter D because that represents our common difference. Okay, the common difference. If I take 9 minus 5, I get 4. If I take 17 minus 13, I get 4. If I do 21 minus 17, I get 4. Okay? If I know the 100th term and I want the 99th term, I just have to subtract 4 to go backwards. Okay? So that's our D. If I'm doing the 100th term, that would be A with a little subscript of 100 next to it. Okay? And also, in this case, we will use the letter N to represent which term we're talking about. So the 100th term has an N equal to 100. Okay? And that's why we could write this as, we could write any term A sub n, that's how we would read that, as the first term 5 plus the common difference 4 times, not n, to get to the nth term, you have to take n minus 1 steps, because you're starting at 1. So it'd be 4 times n minus 1. Okay? So if I want the 70th term, a sub 70 is the first term 5 plus the common difference times 70 minus 1, or 69. Okay? You just plug it into your calculator.
5 plus 4 times 69, that's the answer.
Yeah.
So we should remember this formula.
So the formula, here's the formula that would be helpful to remember. Okay, 5 is our first term, right? So we're going to say that a sub n is the first term, a sub 1, plus, we said the common difference. What do we use to represent the common difference? No, the common difference is
-1, -1.
D.
d, okay? D, and then that's times the n minus 1. Okay? So this right here,
Is A1 stand for the first number in the sequence?
that's right. So 5 is a sub 1 in our example here. Okay? And then, 9 is a sub 2, a sub 3, and so on. Okay? Now, if you understand this, then, as long as you know it's an arithmetic sequence, you can pick these things out. Alright? Let's say you're designing an auditorium. Okay? Suppose you're designing an auditorium, and in the front row of your auditorium, you have 4 seats. And in the next row of the auditorium, you've got 6 seats. And in the next one, you've got 8 seats. Okay? Probably seen auditoriums kind of designed this way, where they have like an aisle going out this way. And you're going to have rows of seats.
That looks so cool.
Okay? So you have 4 in the first row, you have 6 in the next row, you have 8 in the next row. Let's say you're going to have 20 rows.
How many total seats are we going to have?
Well, the total would be actually the sum of all of these, but we can, and we haven't looked at that yet, but we can actually at least look at what how many seats would be in that 20th row.
There'd be a lot of seats. in the
Okay. Alright, so our formula here, a sub n would equal a sub 1 plus the common difference times n minus 1. Okay? So let's identify some of these variables here. What does a sub 1 equal in this case?
4.
Yeah, 4. How many are in the first row? Okay? What would our common difference be?
2.
2. Yeah, it's increasing 2 seats every row. Okay? So if I want the 20th row, what's n equal?
20.
20. Alright? So a sub 20 would equal 4 plus 2 times 20 minus 1. Okay? Using our formula. So we have 4
22.
plus 2 times 19. So that's 38 plus 4 is 42. There are going to be 42 seats in the 20th row. Okay? Now, as we plan this out, as we're designing this, now we actually can figure out exactly how many seats our auditorium will hold, or at least this section of the auditorium will hold. Okay? And that's actually where we get the sum of an arithmetic series. And this one's actually really easy to remember. Okay? The sum of an arithmetic series. I want you to think about this with me here. Okay? if we had 4, 6, 8, all the way up, and we had 42 in the last row.
There's gotta be a formula to do this.
Yeah, there is. The previous row would have how many seats?
40,
40, and the one before that would be
38.
38, and it would count, and we'd meet in the middle somewhere, okay? Check this out, though. This is what's kind of neat. Right? 4 plus 42 equals
46.
46. 6 plus 40 equals,
46?
and 8 plus 38 equals
I believe 46.
46. I can pair all of these up, and I'm going to get 46 every time. How many pairs would I end up with if I'm doing this with 20 rows?
46.
No.
No.
10.
42.
I'm going to get 10 pairs. I'm going to get 10 pairs
How do you 10 pairs?
because eventually we'll meet in the middle here. You know?
How do you know it's going to be 10 now?
Well, because we have 20 rows, right? So you're going to do the 1st and the 20th, 2nd and 19th, all the way until you get to the 10th and the 11th.
No.
All right, so we have 10 pairs. Each one is 46. So guess what? The sum of an arithmetic series can be found by adding the first term and the last term. So,
400 plus 32.
A sub 1 plus A sub n.
This is the formula.
Yep. A sub 1 plus A sub n. And then I want to divide that by, or I'm sorry, I want to multiply that by the number of terms divided by 2. Because I divided by 2 because I'm pairing them all up. So it's times n over 2. Okay? So, think with me here. We have 4 in the first row, 42 in the last row. There are 20 rows, so that means there's going to be 10 pairs. And that means that this is going to be 10 times 46, or 460 seats in this whole thing. We can fit 460 seats in this auditorium as we've designed it.
That's so many seats.
Okay? That's how this works. Now, one cool thing is there's a mathematician, Carl Friedrich Gauss.
Who's that?
He was a guy who lived back in the 1800s, I believe.
There we go.
Okay, or 1700s maybe.
Imagine living back then. No technology.
But here's the thing. When he was in elementary school,
They have horses.
listen please. When he was in elementary school, his teacher gave them the job of adding up all the numbers from 1 to 100. And he derived this idea on his
In
own.
elementary school.
Yeah.
He made this in elementary school.
What do you mean?
Well, he didn't make this for the first time, but he figured this out on his own. This was one thing that he figured out. Now, he figured out a whole lot of other stuff in mathematics. Like the bell curve. It's called a Gaussian model. Okay, then you guys have heard of the bell curve. He developed some of that.
I don't
Okay,
know any of history is true.
How do we know?
because
We
people
only
observed
know
it and
what
wrote
we're
it
told.
down, and
So what? I can write anything down. I can write I saw a unicorn today.
Yeah, but
Does that mean I
today-
saw a unicorn?
yes, but that's why you look at the credibility of the one writing. So if we saw you writing it,
Consider
know.
the source.
exactly, and also you consider multiple sources. You know,
So if
you look
this
at
whole
things
class
that
said we
happen,
saw
a bunch of
unicorn
different
today.
things. All right, so the other type of a sequence is geometric. All right, geometric. Geometric sequences are different in that we're not adding the same thing every time. We're actually multiplying by the same thing every time.
If you're multiplying
Okay.
by 9.
So we could have a sequence like this where we have 1, 9, 81, 729,
1 times 9, 9 times 9, 81 times 9.
and so on. Okay. So, So we have a sequence like this, where every time we are multiplying by 9. Okay? Now, as you can see here, the numbers get really big really fast. Okay? Faster than they did with the arithmetic. This is kind of like, let's just leave that there for the rest of the
How did that
period.
get there?
So, geometric. The idea here is, again, that we're multiplying by the same number every time. So think with me here. If I have a first term of 1, okay, how many times am I going to have to multiply by 9 to get to the 10th term?
10.
If I'm starting at the first term, how many times do I have to multiply by 9 to get to the 10th term? Let's leave it. Please.
9 times.
9.
9, okay? So think about this. Here I have the first term times that 9, and I've got to do that 9 times. If I'm multiplying by 9 over and over and over again, that's the definition of what an exponent is, right? So I'm doing 9 to the 9th power. Alright, so look at that right there. That would be my a sub 10 in this case. Alright? So, we have a sub 10 would be 1 times 9 to the 9th. If I wanted the 20th term, I would have the first term times 9 to what power?
19.
The 19th, because I got to take 19 steps to get up to the 20th one. Okay? So, here's a little, here's our formula for geometric sequences. A sub n is going to be that first term times, and then here's a term that we haven't stated yet. This 9 is what's known as the common, instead of a difference, this time it's called the common ratio. Alright, and we use the letter R for that. Okay? So, we have a sub n equals a sub 1 times the common ratio to the n minus 1 power. Alright, and you can see that right here. A sub 1 is 1, the common ratio is 9, n is 10, so 10 minus 1 is where we got this 9 from. Okay?
I remember this.
Good.
I think we did it last year.
You probably did some. Okay? So that's geometric sequences. Alright. Let's here. Let's say I gave you the sequence 2, 6, 18, 54, 162, 486, 1490, no, not 90, 1458. And I'll stop there.
Wait, can we try it on our own? Like,
Yeah. Go ahead and I want try to find the common ratio, identify what a sub 1 is.
Wait, I think that one's 1448. I don't know for sure.
Okay. Give me a formula for what a sub n would be. Okay? Alright, so what is r here?
3.
R equals 3. We're multiplying by 3 every time. Okay? Every time we're multiplying by 3. So that's your R. If it's not obvious, you can always divide. 6 divided by 2 is 3. 18 divided by 6 is 3. 1456 divided by 486 is 3. Okay? What's a sub 1?
2.
A sub 1 is 2. So if I'm constructing our formula, a sub n is going to equal what?
5.
Just hold on.
2 times 3 to what power? Yeah, to the n minus 1. Okay? So if we want the 10th term,
2 times 3 with the 9 at the top.
yeah, it would be 2 times 3 to the 9th power.
Oh, you lost me.
Okay?
Because n minus 1, so it's 10 minus 1. So that's how you get the exponent of 9, don't you?
Alright.
Okay? So,
Thank you.
that's how we would work with the geometric sequences. Okay?
Yeah, you too.
That's the basic thing that you guys need to be able to do, okay? Arithmetic and geometric sequences. If I give you terms in a sequence, you should be able to identify which type of sequence it is. Okay? And then you should also be able to identify, if it's arithmetic, what the common difference is and come up with different terms for that. If it's geometric, you should be able to identify the common ratio and come up with a term in the sequence for that.
Does it go more in depth, or is this kind of it?
This is it.
Very easy.
Okay?
I like this.
So, let's do an example here where I give you a sequence. I'm not going to tell you which kind it is. Alright, so let's say we've got 25, 21, 17, 13, 9, and so on. Okay?
Easy.
So figure out what type of sequence it is, and then I want you to find a sub 21. Okay?
What?
Alright, so this is arithmetic, because as you look from term to term to term, you're subtracting 4 every time. So your common difference is minus 4. Okay, so as you're looking to find a term for an arithmetic, you got to make sure that you're using the right formula. This is where this gets more challenging, is figuring out which one to use. Alright, so look for that. Am I multiplying or dividing by something? Then it's geometric. If I'm just adding or subtracting, it's arithmetic. Okay, so I've got a sub 1 plus d times
This is the formula?
21 minus 1. This is part of the formula there,
Do
okay?
you have to memorize that formula?
Something you should know, or you just add them up separately on your own.
Well, that's
Okay.
taking forever.
Yeah, I could.
Right.
So a sub 1 is 25.
Can't you also just do
D is minus 4.
Skirt.
And then 21 minus 1 is 20.
So what did you do? Negative 4 times
it should be 21 times
Yep.
20?
Negative 55.
25 minus 80 is a negative 55.
That's a big number, Nolan.
Okay?
Hey.
So negative
It's
55.
not a big number.
Okay?
It's a small number. It's negative. It's
Ooh.
easy. One.
I hide it in my sock.
Alright. One more here. Okay?
Bet you I get like 3 minutes.
Now, we have, let's say, 200.
Yeah, I'm in there.
100. Sorry, negative 100.
Oh.
50. Negative 25.
I'm confused.
12 and a half.
It's just divided by half.
Negative 6 and a quarter.
God bless.
And so on.
I know what
Okay.
it is.
Be
Tell
quiet
us.
I didn't say that.
and write it down. So get your a sub n, then find what a sub 12 would be. Alright, let's figure this out here, okay? You found r. R is
Negative 2.
r, not negative 2,
25. Negative.
negative 1/2. They're getting smaller, right? So you're dividing by 2 every time.
Why is my state?
Okay? Well, 'cause you typed it in. Are you doing 200 divided by negative 100? Okay, you gotta do 100 negative 100 divided by 200 to get the common ratio.
Okay.
I
Okay.
just looked at it and said It's half.
Yeah, you can, if you can see it, that's great. If not, if you're gonna plug it into your calculator, make sure you do the negative 100 divided by 200. Alright, so that's negative 1/2 for R. What's a sub 1?
200.
200. Okay? So if I'm doing a sub n, that's 200 times the negative 1/2 to the n minus 1 power. Now, on your calculator, be careful that you have the negative 1/2 in parentheses. Okay? Because the negative will get squared as well here, or will get raised to the power. So if I'm raising that negative 1/2 to an even power, then what happens? If I've got a negative raised to an even power, the answer ends up positive. If I have a negative raised to an odd power, then I get a negative. Okay, so it's important that you have parentheses around that negative 1/2. Okay? Alright, so in this case here, you had your 200 times the negative 1/2 to the 12 minus 1. And what did you guys get?
Negative 0.09766565.
Okay,
69.
25. Alright,
Was you? Oh yeah.
Yeah.
Is that right?
Yes,
okay.
He's correct.
Let me check.